Hi everybody. In the second screencast in our polynomial function section, what I hope you learn is how to find the zeros of a polynomial function, both algebraically and graphically. I also want you to be able to determine the multiplicity of a zero. So let's get started. So looking at this example, we have some function g of x, and it's equal to x cubed plus 2x squared minus 11x minus 12. And the question is to determine if 1 is a zero of g of x. Well, if 1 is a zero of the function, that means that g of 1 has to be equal to 0. So let's plug 1 into the g function. So when you plug 1 into the g function, you find out the g of 1 is equal to negative 20. Since it doesn't equal 0, it's not a 0. Okay, so thinking about this function, this g of x function, graphing it on your calculator, it looks like this. I set my window to have the y minimum be negative 50 and the y maximum be positive 50 if you want to match it up on your own calculator. But if you're looking at this graph, where are the zeros of the function? Well, the zeros are the x-intercepts, remember? So the zeros are here, here, and here. Now, remember I said the zeros of g of x are the x-intercepts of the graph of g of x. So where are those x-intercepts? You can look at the table of your calculator, and if you look at the table, you'll see that where so look in the column for y, and where you see a 0, those are the zeros, those are the x-intercepts. So the x-intercepts are negative 4, negative 1, and positive 3. So you can see that on the graph, negative 4, negative 1, and positive 3. And those are the zeros of the function. Now remember, the zeros are the x-intercepts, but the zeros are also the factors of g of x. Because remember, the factors are where you find those x-intercepts. So if the zeros are negative 4, negative 1, and 3, the factors of g of x have to be x plus 4, x plus 1, and x minus 3. We're going to talk about this concept in a future screencast, a couple screencasts from now. It's like about 3 sections from here. But anyway, that's introducing that idea of the x-intercepts, the zeros, and the factors are all related. Okay, so let's look at another example. So f of x is equal to x minus 2 times x plus 1 times 2x plus 5. Find the zeros. Well, this is already factored for you. So if you're asked to find the zeros, you're also finding the x-intercepts. You're finding out when f of x is equal to 0. And those zeros occur at positive 2, that's from this factor, negative 1 from this factor, and negative 5 halves from the third factor. Okay, now you try one. Find the zeros of f of x. The zeros, I hope you figured out, were negative 3, 1, and 4. What was different about this example is that these factors have exponents on them. So what we do is we call this the multiplicity of the zero. So in this example, the zeros are negative 3, 1, and 4. And negative 3 has a multiplicity of 3 because that's the power on that factor. That's the exponent on the factor. 1 has a multiplicity of 2. And 4 has a multiplicity of 1. If you don't see an exponent, remember, it's assumed that it's 1. Okay, you try this next one. So find the zeros and state the multiplicity of each of those zeros. I put my answers in a chart. So the zeros are 2, positive 1/3, and 0. And the multiplicity of each of those is 3 for the 0 on 2, 2 for the 0 at 1/3. That's the power here. And for the 0 of 0, the multiplicity of that is 4. Okay, one last example. So I've given you 3 examples in a row that were already factored. What about this one? This one isn't factored. So what we're going to have to do is factor this. So this is not a trinomial, and this is a cubic function. So to factor this, we're going to have to factor by grouping. Do you remember how to factor by grouping? So when we go to factor by grouping, we're going to group the first 2 terms together and the second 2 terms together. I want you to look at how I group these. So 2x cubed and minus x squared goes in the first parenthesis. Everything's good there. And then I have a minus sign. But look at the sign on this 4. It was positive, now it's negative. Do you understand why? It's because if I distribute that negative sign, I need to get back to here. So a negative times a negative would be positive. Okay, so now the next step in factoring by grouping is to factor out a GCF in the first group and factor out a GCF from the second group. So in the first group, we can factor out x squared. That leaves 2x minus 1 behind. In the second grouping, I can factor out a 4, which leaves 2x minus 1 behind. Now that's significant because 2x minus 1 is the same factor. So I'm going to factor that out. So when I take out 2x minus 1, I'm left with x squared minus 4. Pause the screencast if you need to absorb what just happened. I'm not done factoring because I can factor x squared minus 4. So in the next step, I factored out x squared minus 4. So now this polynomial is completely factored. What are the zeros and what is the multiplicity of each of those zeros? Well, the zeros are 1/2, -2, and +2. And each of those has a multiplicity of 1. Okay, that's it. That's all there is to it. This section is done. Good luck. Email me, as always, with your questions.